Okay, so good afternoon, everyone, and welcome to the Toksika Hackathon launch webinar. We are excited to have all of you here as we kick off this journey towards innovative solutions for soil bioremediation. My name is Antanas, and I'll be your host today. This event is part of the Toksika Hackathon, where we challenge teams to develop solutions for accelerating biological soil treatment for petroleum-contaminated sites while preserving microbial ecosystems. During this webinar, you'll hear from leading experts who will share their insights into different bioremediation technologies, the challenges we aim to address, and of course, details about the hackathon itself. A few quick housekeeping notes before we begin. Please keep your microphones muted during the presentations. If you have any questions, feel free to drop them in Zoom chat, and we'll have time for discussion after the presentations. And this session is being recorded and will be shared with participants afterwards. With that, let's dive right in. And our first speaker is Anna Alto from YAMK University. And she will introduce us to the BioBoosters project, which this hackathon is part of, and its role of supporting innovation. So Anna, the floor is yours.
Thank you, Antanas. Just a moment. Okay, I trust you can see my presentation now. And here we go. So my name is Anna Aalto, and I come from BioBoosters by YAMK, Business Accelerator of the Institute of Bioeconomy here at YAMK University of Applied Sciences. We are situated in central Finland, in Jyväskylä, and also in Saarijärvi at our lovely rural bioeconomy campus. And BioBoosters, apart from being the accelerator here in Saarijärvi, it's also a network. And this network extends beyond the Baltic Sea region. We are here in central Finland, as you can see, YAMK, but we have partners in Sweden, Germany, Poland, and in Estonia, Latvia, and Lithuania. Partners have different focus areas in the sectors of bioeconomy. For instance, in Sweden, the partners are more focused on the forest-based bioeconomy, and in some other regions we have more of an agricultural focus. In YAMK, for instance, we are leading especially in the smart farming specialization areas. But together we offer a very cross-sectoral and wide network of networks that features expertise from research field and business field. So we are well connected in the bioeconomy sectors and in the innovation activities there. So all of the partners that you see here on the map represent innovation hub and a connector of the regional innovation system in their country and region. And together we are delivering hackathons as a tool and mechanism to boost circular transition for bioeconomy sector companies. And within the scope of this BioBoosters Boosting Circular Transition project, which brings us here today, we are delivering 18 of these business-driven hackathons, and the aim is to launch up to 20 research, development, and innovation partnerships that are business-driven and work towards these business challenges in the circular transition. The hackathons are a meeting place, an international meeting place that spark different kind of cooperation between research and business, between businesses, and between regions as well. So we are connecting 500 or more specialists throughout this project to drive the circular transition of bioeconomy in the Baltic Sea region. The project has been running for 2 years, so we have entered the final year of the project, and this spring is the final period for our piloting, and then we are closing our piloting phase with these results of the 18 hackathons, and will work towards transitioning to the long-term model for the network operation, and we're going beyond this project-based cooperation. That's the next step for us. But the framework that we are working on is this promotion of circular transition of the bioeconomy sectors. So we want to tackle challenges that relate to sustainable biomass sourcing and optimizing the value of biomass along the production and value chains, to make sure the materials are reused, recycled, and being in the system as long as possible, making sure the nutrients and CO2 return to the natural flows, and we have this sustainable overall economic system in place based on the bio-based resources. And this is the framework from which we are solving different challenges. And the starting point for this is always the need from the company. And based on that need, we will design the next steps. And here is the whole hackathon path. And as mentioned, starting with the need of the challenge provider company, we will define what are the solutions we are looking for, what are the target groups, what kind of expertise is needed, how do we evaluate different solution ideas. So what are we looking for? And we also want to define what can we offer for those companies, research teams, maybe students, maybe private innovators that have an idea that can help to fix this problem, to solve the challenge. So we want to make sure that we create a win-win situation where we are able to not only solve the challenge for the challenge provider, but provide opportunities for these solution provider teams that want to work with us during the hackathon and then work together with the challenge provider in the end. So here we are now. We have formulated the challenge, and we know what we are looking for. We know what we can offer, and that's what we are here to present today at this launch webinar. From here, we start this marketing phase to attract teams to apply and to share their ideas. And by the closing of the call, we will have a selection of ideas and themes for Toksika to take a look and see which ones have the best potential in their view, and based on the evaluation criteria to enter the closed phase of the hackathon process. So the selected teams will receive their invitations to a kickoff where they are able to present their ideas to the challenge provider, to Toksika, and also to mentors, and to get feedback on how to develop that idea further to best respond to the need of Toksika, and to come up with a tangible cooperation proposal in the end of the hackathon process. So the kickoff is the starting point for interaction between the challenge provider, Toksika, the teams that have been selected, and the mentors. And from the kickoff, they start to continue this development work on a digital platform. and getting ready for the hackathon days. So hackathon days are where we start by more intense mentoring and networking and interaction between the participants on the first day. And on the second day, it's time to pitch. So this is where the teams will share their cooperation proposals. And in the end of a pitching session, the jury, represented mainly by Toksika in this case, will then decide who are the winners or which team has won. So the proposal for the winning team in our hackathons is to start a cooperation with the challenge provider and through that cooperation take their idea further and to grasp business opportunities related to the idea. But we will hear the details about this in the coming presentations. But this is the overall process we have been piloting now within the scope of this project for 13 times. And now we also have a pretty good idea of what the results might be. So these are the 13 companies that we have worked with so far. We have worked on challenges or related to valorization of biological side streams, optimizing sustainable use of bioresources with digitalization and smart technologies, and challenges on transitioning to bio-based industries, so replacing fossil-based materials, ingredients, and for instance, packaging. And as a result of the 13 hackathons, we have launched 17 corporations, 10 of them international. We have had 170 applicants and 90 teams selected. Teams come from a range of nationalities. We see all the countries represented in the network, but also other EU and other Baltic Sea region countries and countries outside EU to join in the hackathons. And based on the feedback from over 400 hackathon participants so far, we have a very good net promoter score. So of course your experience as a solution provider may vary as depending on the results of the hackathon, but overall the results have been very positive towards the value from the experience, value from networking, value from learning, and value from this opportunity to connect with the potential clients and work on the idea. We have during this spring also other hackathons going, so just to flip through shortly, we are tomorrow kicking off the Nordic Hemp Hackathon. For some reason there is a wrong date there, but no worries about that. Yesterday we launched the call for Refal to maximize the value of apple biomass. Another apple-related hackathon also was launched yesterday for sustainable use of apple pomace. And today we are here to launch the Toksika hackathon, which the other presenters will share more details about. If you are interested in our past experiences, we have a publication available on the first 9 hackathon journeys of our clients, and this I can share the link in the chat in a moment. And of course, for all the calls and results, please follow us in LinkedIn. But I think that was about it, and I can take some questions maybe in the chat, or how is the plan, Antanas?
Yeah, the plan is to have all the questions in chat. So if you have anything, please let us know during each of the presentation. And after the presentation ends, I'll forward that question to the speaker. So yes, thank you, Anna, for the great insights into the BioBoosters approach. And the next, we will hear more about company behind this hackathon, Toksika. So we welcome Danielius Šeštokas from Toksika, who will share the story of the company and its main activities. So over to you, Danielius.
Okay, I guess everyone sees me and sees my screen. So, good day, everyone. My name is Danielius Šeštokas, and I am pleased to share the story of Toksika, one of the Lithuania's foremost companies specializing in safe and responsible management of hazardous waste. So over the given time for me, we will explore its funding, major milestones, and ongoing commitment to environmental stewardship that has shaped our operations. Okay, sorry. Toksika was created to fill a critical need in Lithuania, a dedicated company to handle and treat hazardous waste responsibly. Over the time, it has become a leading authority in Lithuania's waste management sector, maintaining strict compliance with local and European regulations. So its reputation rests on three core pillars. So first one is safety, second one is innovation and environmental responsibility. To understand us as Toksika, let's step back to the 90s. After Lithuania's independence, industrial and commercial activities were growing, but the infrastructure to manage hazardous byproducts was inadequate. Recognizing the risk posed by chemicals, medical waste, and other dangerous materials, the government played a key role in establishing a specialized entity. So by the early 2000s, these initiatives took shape under one umbrella, formerly known as Toksika. Right from the start, its primary goal was clear, to shield environment and public health from the dangers of improperly handled hazardous wastes. Since its establishment at 92, Toksika has achieved several noteworthy milestones. So I'll mention a few of many. In the early 2000s, we transitioned to a joint stock company, initially set up with significant state oversight. Toksika eventually adopted a joint stock structure, attracting private investment while adhering to stringent environmental standards. As Lithuania's industries grew, so did the volume of hazardous materials. So Toksika expanded to establish treatment facilities in more regions, improving accessibility and rapid response capabilities. After Lithuania's after Lithuania's accession to European Union in 2004, Toksika upgraded its plans and methods to meet EU directives on waste management. This shift underscored commitment to high quality operations and stringent environmental safeguards. In the mid 2014, we finalized the construction of our hazardous waste incineration plant in Šiauliai, which at that time can handle 8,000 tons of waste per year. Now it's increased to almost 12,000 tons. In recent developments, on December 2023, the government of Lithuania approved an increase in Toksika's authorized capital by investing closed company GVT LT shares into our company. This strategic move paved the way to further growth. Finally, in October last year, we completed reorganization of mentioned company, GVT LT, by merging it into Toksika, consolidating all activities under one legal entity. Toksika provides a comprehensive suite of services that highlight its specialized role in hazardous waste management. It ensures safe collection and transportation from industrial sites to treatment facilities, relying on specialized vehicles designed for secure transfers. In-house laboratories meticulously analyze the composition of each waste stream, guiding the most effective treatment strategy. Throughout incineration, as well as chemical and biological processes, Toksika neutralize hazardous materials to reduce their environmental impact. Recognizing the need for compliance, it also offers consulting and training services that help clients maintain safe handling protocols. And finally, where possible, the company emphasize recycling and reuse initiatives, to align with the European Union sustainability objectives. Toksika has earned multiple distinctions that highlights its commitment to high standards in waste management. The company holds ISO certifications in quality management, environmental protection, and occupational health and safety. Local and regional awards from Lithuania's organizations further recognize Toksika's achievements in exceeding hazardous waste management benchmarks. Meanwhile, ongoing collaborations with academic institutions fuel research into more sustainable and effective practices, bolstering the company's drive for continuous improvement. These combined efforts underscores Toksika's unwavering dedication to responsible operations, innovating and the well-being of the communities it serves, ultimately setting a high bar for excellence in the waste management sector. At Toksika, our commitment to excellence rests on four fundamental values. First, we believe in safety, protecting every employee and communities near our facilities with strict protocols that leave no room for compromise. Second, we practice environmental stewardship by minimizing our ecological impact at every stage, from careful processing to responsible disposal. Third, we champion innovation, continuously upgrading our methods and investing in cutting-edge equipment to lead the way in hazardous waste management. And finally, we uphold integrity and professionalism, operating transparently and ethically to earn the lasting trust of regulations and clients, so do neighbors. These principles guide our daily work and define who we are at Toksika. Toksika operates in the demanding sector, facing four key challenges that shape its day-to-day decisions. First, complex regulations across Europe mean that laws are always evolving, prompting continuously investments in technology and specialized staff training. Then community relations require proactive engagement because the term hazardous waste can raise valid public concerns. So Toksika organizes open forums and education programs to foster understanding and trust. What's more important is that the keeping up with technological upgrades is essential. It's important to adopt the latest treatment methods, which are critical investments for remaining competitive and compliant. And finally, economic viability can shift waste volumes overnight, which means Toksika must stay flexible, resilient, embracing every challenge as opportunity to improve and broaden its services. We understand that achieving success also means embracing social responsibility. That's why company invest in 3K areas. It runs educational initiatives with schools and universities, prompting awareness of environmental protection and introducing students to past, present, and future of waste management. Second, it engages in community outreach by holding open house visits and demonstrations, showing the public how hazardous waste is safely managed. Our company supports local environmental projects, participating in cleanups and restoration efforts that help create a healthier Lithuania. Throughout these actions, Toksika strengthens its community ties and builds lasting trust as a responsible company. We are dedicated to reinforcing our position as a top hazardous waste manager in Lithuania by investing in advanced technologies, integrating new methods in waste incineration, treatment, recycling, and emissions control. We also open-minded to expand our regional presence through partnerships with neighboring countries, supporting cross-border waste management solutions and the best practices. Emphasizing the circular economy, Toksika focuses on recovering and reusing materials in line with EU sustainability goals. Additionally, we remain committed to building strong collaborations with government agencies, research institutions, and environmental organizations, fostering best practices across the industry. So in conclusion, Toksika stands as testament to Lithuania's commitment to responsibly handling hazardous materials. From its early days as a government-supported initiative to its current status as a comprehensive waste management leader, it has proven that the company simultaneously meet industrial demands and serve the public good. As we look to the future of Toksika is poised to continue innovating, research and educating. Whether you are an industry professional or a concerned citizen, understanding Toksika's journey underscores the importance of expert hazardous waste management for a safer and more sustainable world. Thank you.
Thank you, Danielius. It's a great presentation about Toksika. We gather insightful insights about the company's activities. So thank you for that.
Thank you.
Now let's get into the heart of today's discussion, the challenge that teams will work on during the Toksika Hackathon. So I would like to introduce the Hackathon. The Hackathon challenge will be introduced by Rimas Meišininkas from Toksika. So Rimas, please go ahead.
So, hello, my name is Rimas, and I am head of Jonava Soil Remediation Plant. Thank you, Danielius, for the nice presentation, and I would like to jump in our Toksika Hackathon. According to Lithuanian Geological Survey, in Lithuania we have more than 12,000 geological pollution hotspots, of which as many as 5,000 were related to petroleum hydrocarbons contamination. It could be gas stations, power plants, oil depots, military areas, and others. Many of pollution hotspots we inherited from the times of Soviet Union. Contamination of soil and groundwater with petroleum products and other hazardous compounds is usually only investigated by special studies, so it's speculated that many of the contaminated areas are still unknown today. So I want to show you what the steps of a real polluted area ex situ decontamination look like. First, we have a contaminated area that needs to be remediated according to a remediation plan. In many cases, it is necessary to excavate not only the soil, but also remove contaminated water, remains of buildings, and sometimes trees. Next, the contaminated substances are excavated, loaded into trucks, and transported to stationary soil treatment sites. Then clean soil is brought in, compacted, and leveled according to the existing terrain. Finally, the area is planted with grass plants and recultivated. And this is the first and fastest part of ex situ soil decontamination. Toksika has two soil decontamination plants. One is in the middle of Lithuania, in Jonava district. It's a very strategical good point. And other one is in West Lithuania, in Klaipėda district. So this department operates in the coastal region. In general, we treat not only soil contaminated with petroleum hydrocarbons, but sludge and water as well. The first stage of contaminated soil remediation inside is mechanical screening to separate big impurities, stones, construction scrap, pieces of wood, and so on. The next step is the formation of triangle soil piles, during which the contaminated soil is mixed with a small amount of straw, wood chips, or grain waste. Some nutrients are added to improve the living conditions of the microorganisms. The special inoculum of soil oxidizing microorganisms is then added at the soil piles, and soil piles are homogenized with a special equipment. And if it will be possible to show the equipment we use. So you can see the self-propelled turning machine used for the soil mixing. In one procedure, we can homogenize all amount of pile to avoid different concentrations in different soil pile sites. And at the same time, we aerate the soil, because aeration and oxygen is essential thing for petroleum hydrocarbons decontamination. And we have an opportunity to spray liquid phase microorganisms inoculum in direct in the soil during the turning procedure. So let's dive again to the presentation. So biological soil remediation method, by remediation in general, are the use of living organisms, mostly microorganisms, to reduce soil pollution. The degradation of organic compounds is usually the overall result of the activity of various microorganisms when they transform pollutants into less dangerous or non-hazardous compounds. So hydrocarbons can be degraded by different types of microorganisms, for example, bacteria, fungi, yeast, and so on. And many hydrocarbons can be completely broken down into carbon dioxide and water in this way. So it's absolutely non-hazardous compounds. In our case, we use bioaugmentation method. It is a treatment method where specially selected and multiplied microorganisms can use petroleum hydrocarbons as a source of carbon and energy are introduced in the contaminated soil. And the main difference from the biostimulation method is that during bioaugmentation, external strains of microorganisms are introduced in the soil, while during biostimulation, the aim is to create optimal living conditions of the communities of microorganisms already present in the soil. So it is a typical biodegradation of petroleum hydrocarbons curve. Right after introducing bioremediation method, biostimulation or bioaugmentation, there is usually a lag phase where microorganisms are adjusting to their environment and activating enzymes needed to degrade petroleum hydrocarbons. During this phase, the contamination level remains relatively unchanged. Once microorganisms adapt and start break down hydrocarbons efficiently, the concentration of contaminant drops rapidly. This is where the most significant hydrocarbons breakdown occurs, typically within weeks or a month, depending on environmental conditions. As hydrocarbons become less available, the breakdown rate slows down. This part of the curve. Long chain hydrocarbons and heavy fractions take longer time to degrade. Eventually, petroleum hydrocarbons levels reach a low and stable level, where only highly recalcitrant hydrocarbons remain. At this point, microbial activity slows down because the remaining compounds are more resistant to degradation. The remediation efficiency drastically slows down because the heavy fraction remains. In order to reach the pollution levels of 1 or 2 grams per kilogram may take another season of remediation. And this is where the problem lies, and the goal is to speed up the contamination at this stage below the red dotted line. So it was a more theoretical curve. I would like to show how does the real curves look like during the contamination season of contaminated soils. So the accelerating phase could be seen in all examples, less expressed on top and more expressed at the bottom. And then comes the slower phase. In first case, we the contaminated soil after several months. In another case, despite the drastic drop at the first month, we had to spend almost a year to decontaminate the soil. So remediating long-chain petroleum hydrocarbons using microorganisms through the methods as biostimulation or bioaugmentation sounds great in theory, but it comes with a lot of challenges. So the last part of my presentation is the goal of the hackathon. So the goal is the acceleration of biodegradation of long-chain petroleum hydrocarbons in contaminated soil without killing the microorganisms. That means without aggressive chemical, physical treatment. According to Lithuanian environmental law, we have to decontaminate and monitor petroleum hydrocarbons fractions from carbon length in range of carbon 10 to carbon 40. With the first fraction of F1, we don't have problems at all. And the objective and main target is to speed up the decomposition of hydrocarbons in carbon range of 28 to carbon range to 40. So to achieve the goal, the participants of the hackathon can offer various options that would be suitable for Lithuanian climate and would be relatively cheap. We are also well studied and implementing technologies such as phytoremediation and the use of biosurfactants and other organic additives to promote the process. Anyway, we are open for any kind of the solution can improve the biodegradation process of long-chain petroleum hydrocarbons. And we are very interested in cooperation with companies engaged in the same activity that have real soil treatment facilities. So thank you very much. And if you have questions, please do not hesitate to ask.
Thank you, Rimas. Do you have any questions at the moment? Okay, I can't see any questions in the comments section at the moment, but if there would be any, okay, I can see the question from Eva. Eva, please go ahead. Eva, do you have a question, or you are still on mute and we can't hear you?
Maybe I have one question. If
Yes, Olga, please.
yeah. Just interesting for the scientist. Do you try to application of different kind of biochars for the more active the degradation of mostly heavy metals, of course, but also it's very helpful for bacteria because we are working with a functionalite biochar. So it will be interesting to know. Are you looking in this direction or it's absolutely not interesting for you?
Yes, thank you for your question. In general, we try to apply some kind of biochar during the remediation process, but we obtain some results that biochar is acting more as a sorbent and not improving the speed of the contamination, but improving the adhesion of the petroleum hydrocarbons. And using of biochar is how to say a little bit too expensive for our amounts of contaminated soil treatments because we remediate about 10,000 tons of contaminated soil per year, and it would be quite expensive to use biochar as an amendment.
It's a questions because we can use production of biochar needs only organic waste, not really. We spend a lot of time for raw material, a lot of not of time, a lot of money for raw material. So in some countries like China, it's they use 20 ton per hectare, for example. It's just example. Thank you.
Thank you.
Olga. We got another question in the comments. So let's start with the question from Eva. Eva is interested about if you know anyone in Sweden dealing with this, and can you point Eva to any direction to companies who are dealing with similar activities like Toksika and the cleaning of contaminated soil?
It's a question for me.
Yes, it's for you.
I don't know really about the companies in Sweden.
Okay. And another question from Anita. Anita is saying that in Latvia it's a big problem with the polluted soil, not only with oil products, but analysis show how also high heavy metal ranges. And how do you manage this?
The contamination with petroleum products is always related with heavy metals, but the ranges of concentrations always is different. I don't know. In our cases, we don't have a very big problem with heavy metals. We can, of course, use some kind of phytoremediation application to reduce the heavy metals or some chemical agents to immobilize and make heavy metals less bioavailable. So that's the point, I think.
Okay, thank you. And one more question from Marcus. Okay, which is already answered by Danielius. So I think that's all the questions. You will have an opportunity to ask other questions later on as well. So thank you, Rimas. And next we will hear from Gintaras Šiaudinis from Lithuanian Research Center for Agriculture and Forestry, who will share insights on the plant-based remediation of heavy metal contaminated soil. Gintaras, please take it away.
Can you see the
Yes, we can.
screen? Yes, so good afternoon, everyone. So we will turn now to the phytoremediation. That means that I will speak about how do plants can accumulate heavy metals from the contaminated soil. As you mentioned, yes, I am from Lithuanian Research Center for Agriculture and Forestry, together with my colleagues, and also one here we engaged in one project together with Professor Olgania from Klaipėda University. So, and we are, so our research center is located in the different places, different locations in Lithuania. So personally, we are located in the Western Lithuania, about 20 kilometers from Klaipėda. And so now, what is the problem? What is relevance of the soil contamination? So is the soil pollution seems have an existing problem in the global scale. So mostly, of course, because of the human activity, and it's a relevant issue which constantly need to find the better solutions. And thus concerning phytoremediation, it is the natural mean, how to say, to clean up the soils by the help of plant species, or to accumulate or to stabilize the contaminated soils by heavy metals, pesticides, and oil products. So the previous reporter with Rimas Meišininkas spoke much about how to clean the soil which is contaminated by the oil products, and it so happened what I also included the same map as he did. Yes, it is from Lithuanian Geological Survey source. Also, we have, I will shortly remind, but yes, we have about 12,000 with hotspots, which are polluted by oil products, pesticides, and heavy metals. But the bigger share is for oil products, and a bit less with hotspots are contaminated by pesticides. It's especially in the countrysides and heavy metals, and this mostly in the industrial sites. Was that it is with the hotspots occupy about it might be 11 or up to 12,000 hectares of Lithuania land. And what the fellow thinks, so that a few years ago, we have an international South Baltic project together with participants, with colleagues from Sweden, Poland, and so on. And our institution, the Klaipėda University, were participating in this activity. So the name of this project is Baltic Phytoremediation. It is the purpose of the project to, to develop technology for the better clean of soil from heavy metals. In this way, we need to select, to look for the different plant species, and so, and in accordance, we were looking how do the different plant species are accumulating this heavy metals: plumpuum, zinc, copper, cadmium, nickel, chromium, and mercury. How do they accumulate there in biomass? And how is this the content of this heavy metals is being reduced in the topsoil, in the upper layer? So, and I will remind that we are already here. I put the text. We are locating in its Vežaičiai branch. It is a small city, 20 kilometers from Klaipėda. It is the eastern edge of the eastern coastal plain. It is and soil, it is naturally acidic, red soil, very acid. It is the, how to say, as looking from the agricultural point of view, it is in many cases our soil are not fertile and not so profitable like in the central or in the northern part of Lithuania. And another, so beside the hotspots which I showed in the previous slide, now there comes question with sewage sludge as organic compound. Yes, it is from one side, it is as a byproduct of the wastewater treatment stations. It is like it might be used as organic material which contain high amount of organic carbon, nitrogen, especially of phosphorus. Was it from it is the positive side, it is the good or might be a good organic matter for plant nutrition, improving soil quality as well as plant productivity. But however, much of undesirable pollutants, especially heavy metals, and to some extent the use of this material is still limited. So in our activity, we use sewage sludge from two places, from Šilutės vandenys and Klaipėdos vanduo. As you see, the content of in this Klaipėdos vanduo, especially the content of heavy metals is quite higher than in Šilutė. It is, of course, it is normally because Klaipėda is much bigger city with bigger industrial activity. As the same, the level of pollutants is in the higher level. Well, and so our experiment was divided like into two experiments, like first subplot and second subplot. First, starting in 2013, here we are investigating the two species, our common osier Salix minimalis and Cupland, and the second subplot, this experiment started from 2020. Here we are included a lot of the species. As you see, here is the list. It is the 9 sites. And let's shortly look what results we do have here. Here the pictures of common osier and Cupland. So common osier is very popular plant species, especially to clean contaminated soils in the different countries. Cupland, it is also perennial crop, but it was interesting how this species can accumulate heavy metals, because we don't have much data about these crops. And this Salix viminalis, well, so here two successive rotations. That means that the stems are growing for 4 years. After that, we are cutting, and after that, the plants are growing anew and they produce their biomass again. So we are calculated not these numbers not in relative but in absolute numbers. So to look how much of these heavy metals is being removed by this biomass from one hectare. As we see, the highest amount is zinc is accumulating in biomass from 2.5 up to even 2 kilograms per 1 hectare per one rotation. It is quite a high level. The second place, as you see, copper. After copper comes nickel, lead, and you see the rates in the left side. So the highest rate of sewage sludge we used, of course, the highest concentration of heavy metals in biomass. But in the second rotation, this process is going a little bit in slower pace, not so at the first rotation. Well, and the average amount of accumulated heavy metals in silicium polyatom or couplant, it is already not per 4 years or just per 1 year, per one season. Also, heavy metals are accumulated in the biomass in the approximated the same sequence like for the salix liminalis, so zinc, copper, nickel, lead, chromium, and mercury was almost everywhere absent, so we do not count the existence of this not element. And as I told, we also used another grassy crop. So here Artemisia dubia, Miscanthus giganteus, which are two plant species can grow as energetic crops for energy purposes. Also the annual well-known species like sunflower, maize, and buckwheat, they are annual, and thus we need to seed them every spring. And what do the results have? So here the average results, so not for one or for the second season. And what do we have? So sunflower show very interesting results. It might be as a super accumulator of zinc, of copper, of chromium, of nickel and lead. Yes, and Artemisia dubia, the species is it belongs also, as we can see, accumulate quite a higher level of copper, of cadmium. The only thing I can remind that zinc and copper also might act as micronutrients for plants growing when they are in small amounts, but of course they become toxic when we use this sewage sludge in higher amounts. Yes, so once plants have a high potential to accumulate a higher biomass, especially with sunflowers we saw in parallel, they can clean soil from heavy metals more faster. And the use of sewage sludge also, it also have problem with the heavy metals leaching into the deeper layers, and thus it is important to cultivate plants who have the strong and deep rooting systems. In this way we can prevent from metals and from the leaching to the groundwaters. Yes, the single application of sewage sludge, as I mentioned, it can support plant species with nutrients, with maintain stable biomass for some or even more years ahead. Yes, despite this phytoremediation, it is the relatively cheap method, but of course it needs a long time. And we also need the more time to investigate, to look for the dynamics, how do different plant species are accumulating these heavy metals in their biomass, or how do they are removing or cleaning soil for this pollutant. Yes, and sorry, we had very little time, only 10 minutes. I think I already exceeded, so I did not show any other interesting results. But the thing is this. So here is the last photo where we gathered together two years ago in the September month. Here we had field days with our partners and also guests who are interested with phytoremediation and how make the environment cleaner. And sorry, I spoke maybe too long, so thank you for attention, and that's all.
Thank you, Gintaras. There is one quick question, but please try to be very quick as we are short of time.
Yes.
Lina is asking, what impact does this process have on the plants themselves? Do they show signs of stress or anything like that?
Actually, we did not find any significant stress on this on their plants or on their growth of the developments. Maybe if we have laboratory experiments, maybe we would see more clearly, but under the field conditions, no, we did not see it.
Amazing. So thank you, Gintaras. Thank you for your
Yes.
time and your presentation. Let's move on. And now we have Markus Ortner, who will talk about European research project focused on soil remediation. Markus, the floor is yours.
Okay, can you see the presentation?
Yes, we can.
Okay, perfect. So thank you very much. Good afternoon, everyone. My name is Markus Ortner. I'm the coordinator of Horizon 2020 funded project on phytoremediation and biofuel production. I'm very happy to be here today with you. And yes, I would like to start with my presentation. Yes. So before I start, so I'm from ITS. This is a small company located in Vienna, Austria. They supports industry in, let's say, developing research ideas and transforming them into concepts and funding. We have more than 15 years experience in coordinating such proposals on national and of course also on European level, and we are managing any kind of research projects, all sizes, from single client initiatives up to international cooperation with more than 20 partners. Okay, that's from my side and from my company. Let's jump into our project. In order to transform soil situation shown here on the left side into improved states shown here on the right side, several remediation methods are available: physical methods, chemical, mechanical methods, and mixtures of it. All of them come along with some disadvantages, which are, one of it is the cost factor. So this was actually the starting point of our project. We wanted to develop a cost-efficient approach, which provides two key benefits, let's say, at the same time, to restoring healthy soils and generated added value products that can be integrated in the circular economy. Key for this is phytoremediation. Yes, as you can see here. And yes, here our project called Phytoclimate in a nutshell. Here you can see the process from contamination, remediation up to in the best case to have a remediated arable land. And then you can see here the crops, the use of the crops feeding into two, let's say, routes. One is the drop-in biofuel production, and the second one is to use one of the outcomes in the metallurgical industry. Our project consists of two, let's say, key pillars. One is the technical one, consists of the biomass generation by phytoremediation and the conversion of this biomass, and the second one deals with different, let's say, SSH aspects such as social acceptance, the LCA, so the environmental impact footprint, legal issues, and of course, economic viability. Okay, here on this slide, you can see our project partners network, the geographical distribution. You can see most of the partners are located in within the European Union. We also have some partners outside the European Union, for instance, Serbia. We have also one prominent partner from Lithuania. It's a small SME company in the field of phytoremediation and soil sanitation. It's called BioValla. And apart from this, we also have partners in South America and Argentina. INTA, it's a very huge national research organization. And at the very beginning, we also had a partner from India, but due to the pandemic, we unfortunately had to, we lost them actually as a partner because it was too difficult to work with them. So we started in 2021. We still have 17 partners. We have 16 partners now, 2 continents, and we are operating 4 pilot sites where we are demonstrating these phytoremediation activities. And apart from this, we also have, let's say, a pilot plant or a pilot biorefinery where we demonstrate the valorization of the harvested biomass. Yes, all in all, we have 5 SMEs, 2 large industries, 1 governmental institution, 1 association, and 8 research centers or universities. Good. So the first step, as I said before, the key step is the phytoremediation and biomass production. Here you can just see a rough overview how the process looked like actually. We are already on the final stretch, so by end of this June, we are finishing our project. And yes, at the beginning, of course, everything was done on small scale, so the partners were looking for the optimal crops, best crop setups, checking different types of amendments and so on. And when they found out the best setup, this was transferred then to a bigger scale, to a field site, and was implemented and operated for at least 3 years. You can see here our pilot sites. They're located in Argentina, Serbia, Lithuania, Spain. And at the very beginning, we had also one in India. And we are covering 2 main types of contaminants, heavy metals in Argentina and Serbia, and petroleum hydrocarbons in Spain and in Lithuania. I would like to give you some insights about the pilot site in Lithuania here. This is a former oil base. Contamination is petroleum hydrocarbons. You can see here the range is between a couple of 100 milligrams up to 7,000 milligrams per kilogram. The site area is about 2,500 square meters and is located in this province of Shaoli. Here on the right side, you can see some photos of the very beginning in April 2021, where the site was prepared. Here in March, it was finalized and ready for the remediation trials. Yes, this site was distributed into 3 different plots where different crop types were applied. It was amaranth, Jerusalem artichoke, and a plant mix, a herbaceous plant mix. And here, yes, and of course, they also were checking different types of amendments, organic, mineral fertilizer, and of course, the addition of supporting bacterial strains. These plots were monitored on a permanent basis. So the crop size, weather, soil data were monitored. And of course, the biomass harvested was also characterized at the end. Just some results as an overview. You can see here the crop type applied. You can see the specific yields in ton per hectare dry weight. So you can see these specific yields were more than 10 tons. And if you compare it to the yields on crops grown on non-contaminated land, you can see we have a big advantage. So you might ask, so how can this be? No, these yields are related to conventional agricultural practices. That means here in these experiments, the team from BioValla also tried out alternatives in terms of, let's say, shrink or reducing the distance between the seed rows and also the densities and the amount of seeds for instance, per square meter. And as you can see, it works. This results spans a period of almost 3 years. And if we look to the TPH removal rate, this was also quite excellent. As we can see here for the herbaceous plant mix, this was the best. So this works really well with a rate of more than 90%. For the Jerusalem artichoke, we can also see a rate activity of a bit more than 50%, and amaranth is about almost 80%. Our goal actually was to achieve a biomass yield of more than 85%. And if you look on this, we can say for Lithuanian pilot site, it works quite well. It was excellent, actually, to say. So if you also look to the other side, so Spain, Serbia, Argentina, you can see in Spain we introduced sorghum. It is an industrial park. The contamination is also petroleum hydrocarbons. The concentration were up to 5,500 milligrams per kilogram. And yes, the removal rates were also quite good with about 86%. In Serbia and Argentina, we were dealing with heavy metal pollution, where Argentina was quite a special case. This was, as you can see here on this photograph, it's a former gold mine, and the concentration of arsenic was tremendous high, with more than 6,000 milligrams per kilogram. And here we were applying local shrubs, so which shows a quite good, let's say, uptake rate, but has the disadvantage that they're really, really slow growing. That means for the second phase in our approach to use biomass for creating or generating added value, it didn't work out. So just some words for what happens after this. So we use the harvested biomass in a so-called thermocatalytic reforming process. So this is the heart of our biorefinery. And as you can see here, the biomass goes in and we create 3 different intermediates, a gaseous, a liquid, 2 liquids actually, and 1 solid intermediate. And oops, this was too fast. Yes. So, and I will not go into details here so much, but here you can see how these products goes into this scheme. At the end, we produce, or we are able to produce biodiesel from the oil seeds. We are able also to valorize the water, the aqueous phase from this core process, which also contains, let's say, a significant concentration of CO2, and this is possible. And we also can produce diesel and marine fuel. And here on the left side, you can see also the coke. Yes, so this was already achieved at the very beginning. So the requirements for the rapeseed methyl ester are completely achieved. So this was done. So the electro-oxidation, this is actually the technology what we apply here for this water treatment. This shows also very excellent results with a COD removal rate of more than 90%. This was actually the most tricky part, and it's still a tricky part. So the gas to liquid process, where we try to work with Fischer-Tropsch at the very beginning, but this was quite challenging. So we moved from Fischer-Tropsch to a Synol process, which is a bit more robust, but at the end of the day, you also create a very strong and powerful oil, but you cannot use it directly. You still have to refine it. And yes, and the oil, which also comes out as an intermediate from our TCR plant, also showed very good characteristics, and we compared it with the requirements, with the standards, and it shows really excellent characteristics. And the char, where actually in case of heavy metal contamination, I mean, when we use biomass which uptakes heavy metals, then in this phase, in the solid phase, most of the heavy metals are accumulated. And we are working together with the world's biggest copper recycling company. It's called Arubis. And they need for a specific process step a coke. At the moment, they use pet coke. And we are trying, or we tried out, if this biochar, this biocoke could also work. And it showed really excellent performance. And yeah, this is actually the way how we valorize our contaminated biomass, because this was actually the biggest issue. I mean, phytoremediation is nothing which was invented by our project. I mean, this exists since many decades. The problem was always what to do with the biomass which contains heavy metals, for instance. And here we found a really nice, smart way how we can valorize them. You can see here the crops, it contains the heavy metals, it goes into our biorefinery plant. So we produce the biochar with the heavy metals, then we have the copper smelting process. They accepting a lot of different waste materials containing probably the entire periodic system. So, and they are able to recycle the copper, pure copper, and two others, which byproducts. It's a slag and a fly ash, and the fly ash here contains the zinc, lead, and others heavy metals. And this is a quite, let's say, a good high value sludge, which goes, for instance, in the zinc industry, and where they can get out the zinc and the lead, for instance. And at the end of the day of this fractionation process, we have a low value sludge which will be concentrated and can be landfilled at the end. Yeah. So, okay. Just a little bit about economic viability. I mean, we are a research project, so we're starting at a TRL 3, and our goal was to end up at 5. But still, we wanted also to check the business possibilities and the economic viabilities. And here you can just see some numbers. I mean, these are ranges because it depends, of course, on the land, the country, depends on the contamination, and then a lot of different other parameters. But you can see here is typical methods: soil washing, ex situ, especially when you have heavy metal containing soils, or excavation. Then you have the incineration process when you have organic pollutants, which cannot be degraded on site, chemical oxidation, immobilization. You can see here the prices per ton per hectare. I mean, the ranges, and you can see the range is between 100 up to 600 euros per ton. But this is quite a lot. But if you look to the treatment speed and the duration, this is, of course, a big plus for these methods, because they're really, really fast. And if you look to phytoremediation, phytosanitation, especially to our project, our business people calculated. So they were really calculating, I think, 3 years and collecting different numbers, working with these numbers. And at the end of the day, our approach would cost between 20 and let's say 45 euros per ton. If you transfer this to hectares, it's about 100 to 200,000 euros per hectares. But the disadvantage, of course, it's slow. It means in the best case, probably it can take up to 5 years, and in the worst case, so we have to think about treatment times about 20 years and even more. If we, and we do it actually in our approach, couple this process of phytoremediation with a biorefinery, with a biomass valorization, we can and we are able also to generate some income streams by these products labeled here. Okay, the conclusion, phytoremediation is very effective in soil remediation. The crop yields, what we have demonstrated, are comparable to those from the non-contaminated land. Stabilization and also remediation have been successfully proven. And this is, of course, a big plus. Contaminated land can be utilized as a carbon feedstock source. And yes, conversion, as shown before, into value-added products such as char, biofuels, and others have been successfully demonstrated, and also the economic feasibility. Our future prospects and outlook is that we would like to scale up this approach to larger scales. I mean, at the moment, our pilot sites have sizes between, let's say, a couple of 100 square meters, and the biggest one I think we have in Serbia is about 4,000 square meters, but we would like to demonstrate this also on a bigger scale, and we also would like to expand a collaboration with different diverse stakeholders in this field. Yes, here's some photos from the Fight to Climate team. Nothing would work with a fantastic team in the background, which do a really fantastic, excellent job. Thank you very much to everyone who is participating in this project. And yes, with that, I would like to thank you for your attention. And if you have any questions, I'm happy to answer them. Thank you.
Yes, great insights, Marcus. Thank you for your time and your presentation. If there will be any questions, you can contact Marcus directly, as there are no questions at the moment in the comment section. So to close the presentations, let's hear from Michal Slota from Nando, which was challenge provider for the BioBoosters Hackathon last year as well. And Michal will discuss how biostimulants can enhance microbial activity in soil bioremediation. So, Michal, over to you.
Thank you so much. Thank you so much. And it's a real pleasure. I would be able to share some of the insights. I joined recently, Nando, as head of marketing, but I have pretty good background in science related to this topic, as I was actively working on the metallophytes in south part of Poland, working as a researcher at the University of Silesia. And right now, I have quite a wide experience with working with with bacteria to help in some of the project. But I will start the whole story with a little bit of a distant perspective that I usually do. That if let's consider some future perspective, if we would ever be able to do any farming project outside the Earth. So there are some NASA plans regarding to get a red planet more green. So it's even possible to have the planet that has no soil, has 95% of carbon dioxide in the atmosphere, only some traces of oxygen to make it possible to even try a farming project. Definitely not what we could tell at the moment without the help of the bacteria. So there was some preliminary examination by NASA to test the bacteria that are potent to propagate, that are potent to tolerate the conditions without oxygen, with high UV radiation, without almost no nutrients on the planet, of course not on Mars, but on some similar environment in Earth, simulating that condition. So definitely microbes could be the helpers. And I would like to showcase during my short presentation here some of the mode of action of the bacteria and tell you at the end about the product portfolio of Nando. So generally, when we take into consideration the role of plants, bacteria, and the soil conditions that are all like Rubik cube, we have three different axes that we need to take into consideration. Thinking about any kind of the projects, focus on the bioremediation or generally stimulating the crop yield potential. So there are these three different type of complexities that we need to take into consideration, and we have a lot of the uncertain condition around, so environmental stresses, biotic stresses. So it will be like fixing that Rubik cubes, the total darkness where we do not know what would be the final outputs. But what we do have in our favor is that we could use the exceptionally diverse environment of root system. You can see here the time-lapse video of root hairs development inside the soil. Root hairs that create that amazing interface of the connection between the plants and bacteria. So if we could employ that powerful connection to some specific function, we could benefit both the yield and the quality of the soil. So in this environment, we've got that very vivid connection between all that living organisms that transfer chemicals between each other, that forms that amazing pathway for transporting water, transporting nutrients throughout the soil between the rhizosphere close to the roots, the detritosphere with the dead biomatter, and to the bulk soil. And all the functions of the bacteria and the plants inside are all interconnected, because the bacteria are in fact the foundation of most of the root system related functions. So we cannot tell about the proper development of root phenotype and its function with no bacteria taken into consideration. So we have that huge advantage of improving the nutrient uptake, including the macro elements like nitrogen, potassium, phosphorus, or sulfur. Then we have the huge effect and an important function on the composition and degradation of pollutants that I would address in a couple of next slides. But we have also effect on all plant phenotype conditions, like improving tolerance to environmental stresses, affecting the growth rate, so increasing the biomass accumulation by the bacteria, then improving the pathogen and pest control, and last but not least, finally finishing with the yield factors. But how it makes us the problem with the soil pollution that is widespread all over the world is that if we focus on specific microbial consortia for the soil phytoremediation, we could help to control some of harmful conditions. So it may be related to the heavy metal contamination. It may be related to some organic contaminants like pesticides or other plant control ingredients. So we have a magnitude of different factors that could be controlled with specific bacterial consortia. So starting with the heavy metals that I did have quite of hands-on experience working on both plant and microbial models. So there are a lot of variables, a lot of the mode of action, how bacteria can make the harmful heavy metals, including lead, over excessive zinc content or cadmium. So they could be involved in the biosorption, so sorbing on their layers the excessive amount of metal, the bioprecipitation, so getting the precipitated in the soil surfaces, bioassimilation, so making the biomass available, the metal available, accumulating it by the bioaccumulation. So the same as phytoaccumulation, bacteria can also accumulate heavy metals to make them more neutral in the soil surrounding. All the biodegradation, one of the processes that enables making them less harmful for the living organisms. And there are specific groups of described bacteria consortia, described filamentous fungi, yeast, and algae that are involved in specific heavy metal removal from the soil, metals including chromium, copper, arsen, cadmium, zinc, or lead. So we have knowledge what type of microbials could be used to employ in the phytoremediation, in the bacterial remediation processes. And other aspects are the plastic pollution that affects the yielding potential of crops pretty fiercely. So there are also described groups of specific bacteria that are potent into degrading almost all kinds of different plastic pollution compounds. So there are both the fungi and bacteria from the group like Streptomyces, Micrococcus, Bacilli, Rhodococcus that could effectively degrade that pollution and make them less harmful to specific root-related traits. And then we have the pesticides, one of the biggest traits in the European Union or in South America, with a huge amount of compounds that could have a long-term harmful effect. Is this described role of specific bacterial enzymes that could be employed, that could be identified and produced, or specific leadering consortia of bacteria can be used in biostimulant products to make this compounds less harmful. So in the summary of the function, I will tell that specific bacteria and fungi could be employed to the formulation of the final product, but the consortia need to design on the way to make them functionally productive. So they need to employ the components of this consortia that would affect specific traits, although related to the phytohormone synthesis, to the control of pests and pathogens, or the degradation of specific organic or non-organic pollutants. And regarding the Nando portfolio, Nando is the Lithuanian company that has more than 50 different products from the adjuvant and microbial biostimulants categories. That's a wise strategy to design the consortia on the functional way. So we are quite interested in the project related to remediation of the soil. We had quite an extensive amount of trials, how the bacteria affect the yielding potential, but we would be still quite open establishing some new cooperation. The remediation projects that could employ some of the consortia that we already have in our portfolio, in our R&D pipeline, and use them for remediating the contaminants in the soil. So thank you for your attention. It would be open in case of any additional questions.
Okay, amazing, Michal. Thank you for this valuable information. It was really interesting to hear it. I can't see any questions at the chat at the moment. If you have any questions, you can let me know and I forward it to Michal. So that was our last presentation for today. We hope that today's session has been insightful and inspiring. If you have any further questions, as I mentioned, feel free to connect with us. The Toksika Hackathon is an exciting opportunity to work on a real-world environmental challenges, and we are looking forward to seeing your innovative solutions. In the few following days, you will receive an email with all the further information regarding the Toksika Hackathon and the recording of this webinar as well. So big thank you to all of our speakers for sharing their expertise, and of course to all of the participants for joining us today. See you soon, best of luck, and stay in touch. Thank you very much.